Thanks for joining us. This is our Astar Tech Talks number 9. So hopefully everyone's here today. Join us to see how we set up a Raspberry Pi for Astar Node. Today we have Benjamin with us. He's from our DevOps team. So,
Hey,
you want to introduce yourself?
hey, GM, Dustin, GM, everyone. Hi, it's nice to be here, sharing some knowledge about Astar Node. So, yeah, I'm just a few words. I'm working in Astar Network as DevOps engineer. So, just to be very quick, it kind of, deal with the nodes and also experiment some things. So, especially little things like this. Raspberry Pi is something I really like, especially with the peer program we have just set. So yeah, that's why we're here today.
Fantastic. So, guess we'll just jump into the demo if you want to get started.
Yep. Sure.
So, give you guys a little context on what we're doing here. So we'll be showing how to configure the Raspberry Pi on USB, configure the SSH, and then configure the Raspberry Pi, and then we'll be running the Astar Arch 64 node. Is that correct?
Yes, it is. Yeah. So may I start? Oh, actually, I will share my screen. It will be easier, and I will show you what we are following today. Here we go. Can you see my screen?
Let's see. Yeah, we can see your screen.
Yeah. Okay, great. So yeah, here is what we're going to go through today. To set the Raspberry Pi, so I did kind of a cheat sheet to help you with the commands and with just a few words. So basically having this video today and just following up this, just a few steps here, you will be able to set up your Astar node on a Raspberry Pi. So first of it, let's start with the hardware, which is the most important. So I will switch my camera to the hardware here. Yep, what you will need today for this is a Raspberry Pi. So here it's in a case. It's a microcomputer, just like this, not bigger than that. This one is a 2 GB RAM version. So it's kind of small. It works for the demo, but it's recommended to have minimum of 4 GB one. Oh, I can see the light is not, yeah, it's better here. So yeah, I would recommend the 4 GB. What you can use actually is one case like this. This one is 8 GB. That is already set, so I will not use this one. But this case is really great. You can find it everywhere on the internet, just buy it online or anywhere if you have a hardware shop next to your home. Why is it great? Because it has a little fan here, and you make sure your Raspberry Pi never, hits too much, right? I also set these little ones. I will look closer. These are the heaters because there is the CPU here and a few chips that you don't want to overheat, because as it's a very small computer, it has a tendency to hit when you use it intensively. And having an Astar node can be intensive. So yeah, this is what I can recommend the best. So Raspberry Pi 8 GB of memory, Raspberry Pi 4, and 4 is very important. Why? Because we will use 64 bits architecture. So a Raspberry Pi 4 is important for this. You may have troubles working with previous versions. All right. What else we're going to need? A small memory card. It will not be used for long, but you will see we use it just to make the Raspberry Pi able to boot on the USB on your disk. So this one is perhaps too much light. It's just 8 GB, very standard one. You don't need even 1 GB for it, but you need a hard drive. So SSD will be much better. Why? Because when an Astar node is syncing to the network, to the peers, it asks a lot of things to the disk. So this one is even NVMe version. So NVMe is not necessary. Why? Because we are working on USB, right? Because Raspberry Pi doesn't have a lot of connectics, but it has USB. So yeah, use USB, use SSD drive. I would recommend 1 terabyte for the drive, all right? And just power cable, right? And that's about it. Eventually, you can use, this cable, which is HDMI with micro HDMI, because Raspberry Pi takes micro HDMI as a display. But actually, with what we will be doing, you don't even need the display, because we will access the Pi differently. All right. So what about we get started? So let's get back to our little cheat sheet. Here it is. Yep. Just waiting a few seconds that everyone can see it sharing. All right. So this is what I just said to you. The requirement, 2 gigabytes is really the minimum. But we recommend 4 gigabytes of RAM, for running an Astar node. All right. So first thing we are going to do is to allow the Raspberry Pi to boot from USB. Why? Because by default, actually, Raspberry Pi installs the operating system on the memory card, on the SD card, but it's not very reliable. SD card can get corrupted, and since you're going to use it quite often, with a node, it's much better if we can boot it directly from the disk. All right. So first software you need is this. So little Raspberry Pi imager. All right. So just go to download it, any operating system you have. So you can download. Here I'm on Linux, so it proposed to me Ubuntu, but you have for Windows and for macOS. So that's not a problem. But if you use Linux, it's even easier because you can install just with this command. All right, it's available in the APT package. All right, so let's switch for now to this program. If I can find the screen. Dustin, how is it going now? Are you ready to order your Raspberry Pi?
I'm ready. As ready as I could be.
Awesome. All right. So you should see my screen now on the Raspberry Pi Imager program. All right. This is a very small app where we will be choosing both things. First one will be to update actually the firmware of the Raspberry Pi to boot on USB rather than on the SD card. And so we are going to copy that on the SD card because it needs it to update the Raspberry bootloader. So it's an internal memory that is inside the Raspberry and that we need to update first. So first of all, taking my little card, insert into my computer. So choose an OS. I was not on the main menu. Yeah, so first one for this one, we are gonna start by the miscellaneous utility images. All right, so go into MISC utility images, select the bootloader, and wait, and we are going to select this one, the USB boot. Okay, so this is bootloader for my Raspberry, and I'm going to choose the storage now. This is my SD card, the one I just inserted. All right, easy like that. Just click on write. All existing data, of course, don't use a card where you have your data on it. It will erase everything. Okay, ask me for password. This one will be very fast because it's a very small program. Luckily, the second one, I had it cached on my computer, so it should be fast enough too. I wanted to prepare writing on the card before, but I thought, you guys would have the good timings and you will see definitely all the steps that we are going through, so you can have a good idea about what we do. I can see and looking at the comments at the same time, someone says he's done it on his node for Bitcoin and Litecoin. Is this similar? Yes, this is similar process, but this is probably even easier. Actually, I never did with Bitcoin node, but you can see how easy it is. What we are doing right now is just prepare the Raspberry Pi. So this is common to anything you will do with a Raspberry Pi. Oh, operating system did not mount. That's something I didn't expect. All right, so excuse me just a second. I'm just going to put, because probably my disk isn't in the best state, so I will just eject it or insert it. Okay. Yeah, seems to be fine. Actually, we are going to test. Even if we have a problem, we will do it again. So let's switch back to the camera here. Yes. So going to the Pi here. Oh, if you can see it right. So what we're doing, just plug actually this card on the back of the Pi, right? In this way. Just insert it and plug the Pi, all right, to the power control. Right now, yes, that's exactly what we want. As I will try to show you, or maybe here will be better. There isn't the best focus here. Yeah, you can see here on this side is the green light, all right? You have two lights, sorry for the color, but here is the green light, all right? And when the green light is blinking like this, it means your bootloader has been flashed. All right, so you are on the last version that allows you to boot. So just let it go for something like 10 seconds, and it will be fine. If we want to make sure, like completely sure about it, I can just plug the cable, the micro HDMI cable, to my screen. Sorry, I will just replug it. All right. So just plug this cable and you will see on the main screen. And it should turn actually green. So I'm gonna unplug and replug. All right, so that we can, now it has Raspberry. Plug it in. Okay. I guess I don't have the picture on the screen. So let's keep this part. It's all right. We don't need it. All right. So my Raspberry is flashed now. So I will just disconnect the power, okay, and remove the SD card. All right. Now, what I want to do is to install actually an operating system on my USB disk. So I will just plug the USB disk to my computer, and we are going to get back on the little program, the Raspberry Pi Major. All right. Oh, it's a bit dark here. Yep. So let's switch back to the little program. Oh. Yeah, that's not super practical to switch between different screens. Sorry for the delay on it. Yep, here we are. So can you see the screen now?
Yeah, I can see the screen.
Okay, great. So what we are going to do here is very easy. We are going to choose now the operating system we want to install. My recommendation, and that's what we are going to use today, is to use Ubuntu and not the, the default OS. Why? Because Ubuntu has some libraries that are easier to use with the Raspberry Pi and the Astar node. So we're going to choose other general purpose OS. We're going to go to Ubuntu. And here, let's select the long-term services. Where is it? On a 64 byte, but we are going to take, this one. So the Ubuntu server on the LTS. LTS is good because it will allow you to have a stable package and long-term maintenance, and make sure it's the 64-bit version, all right? Because your Raspberry Pi 4 is a 64-bit architecture. All right, storage. So now what I take is my hard drive that is just plugged into USB. And before we write, we're going to go in a few options of configurations. So right here, you see, I have this setting button. It's possible that you don't have this setting button. So if you don't, just report to the cheat sheet, and just actually what you need to do is press Control, Shift, and X. All right, and this opens the advanced setting for my Pi. This is where we are going to set the main parameters for our Raspberry Pi. So give it a name. So I called mine Astar Pi. Call it whatever you want. Just keep this name, in memory, because this full one, astarpi.local, is the address you will use to access the Raspberry Pi. Okay. Enable the SSH. This is what's going to allow us actually to connect to the Raspberry Pi without having to plug a screen or to plug a keyboard or anything. You will connect directly from your computer. All right. So for this one, we are going to use password authentication because it's easier. But if you want to improve the security, which is not very necessary when you're at home, but you can allow a public key. All right. So public key is a pair of key generated, and that will allow you to connect without having to type a user password, and it's considered much more secure than a user password. But it's okay, we're on a home connection. So next one, don't forget to set username and password. This will be your user to access the Raspberry Pi. So mine is BLD. I already set my password. And this one is interesting. I will configure the Wi-Fi directly. Okay, the wireless LAN actually allows me to set the SSID, which is the name of my router at home. My router name is SL1. You can see it's the one I'm connected to. All right. And the password. Just like this, and the Raspberry Pi will connect automatically to your Wi-Fi. Some may recommend to use the Ethernet RG45 cable that you have here. Just know that sometimes the RG45 port of the Raspberry Pi can have troubles handling the 1 GB connection. And so it may work with some flaws, and you may have to fix it. So if you like to tinker, use it, and you will have some fun, and probably you will have trouble connecting to it, well, at least with some routers, because it all depends on your router. But if you prefer to have it unplugged, actually the Wi-Fi is enough. Why? Because we will not need, for this type of node, we will not need a very constant connection. And if we lose connection from time to time, it's okay. All right. You can just set local parameters, and this one are just, some basic options that you can. All right. So just save your parameters and write it to the disk. So, of course, all existing data will be erased. So yes. Type in my password again. I wish this one goes fast enough because the image is cached on my computer, so it will not have to download it. But let's wait for a few seconds. All right.
So yeah, I guess we can ask a couple questions here.
Yeah.
So, so what kind of Raspberry Pi model should they be using?
So as I said in the beginning, I would recommend to use a Raspberry Pi 4 and the 4 GB memory minimum. We are going to see today how to deal with less than 4 GB of memory, but I still recommend to use this one, because 2 GB can overload your Raspberry. Of course, Raspberry is actually just an example, which means you can use any kind of small system that is based on an ARM architecture. For example, phones, like not iPhones, but most of Android phones are based on an ARM architecture. So, of course, it depends on the power of the phone. But if your phone is powerful enough and like you have an old phone that is powerful enough, and you want to let sync with an Astar node, you can actually, right?
Interesting. Nice.
Okay, so you can now remove your disk. You see, it's been fast enough. Just because I had the image already loaded, it was less than 2 minutes, right? If you have to download the image, it's 1 GB, so it will depend on your connection, of course. All right, so what's happening now? Just eject this hard drive. All right, I will stop sharing the screen. And get to our line here. Yep. So preparing the Pi, make sure the SD card is removed. All right. And just plug your disk, actually, the one you just installed the OS on, to the USB port. Use the blue port that is here to make sure it's an USB 3 and you have the full speed of USB 3. All right. And then just plug the power cable. So I'm going to try one last time to plug actually the screen so I can show you the start screen, but this is actually not exactly necessary. Right now we are going through the install process. So actually the OS is installing itself on the Raspberry Pi. All right, I will plug again this cable and see if the magic of the direct can still act. And let's plug this. I think my cable has problem. My HDMI cable. Nope. Come on, little guy. And the direct is even more magic when you can't plug the cable. Do I have fat fingers today? Okay, let's play this one. And the magic doesn't happen. My screen is black. That's probably because I didn't actually initiate to do it. All right, this is not a problem. Let me just test. So actually, we're waiting. The Raspberry Pi is blinking. I don't know if you can see here. I will turn off the light. Yep, you have a little green light that is blinking sometimes. All right, which means right now it's probably already installed. This is very fast installation. So let's get back to it, and I'm just making a small test. Yes, nice. All right. So let me share my terminal now. Mm-hmm.
I want to remind everybody, check out the cheat sheet. So you want to follow us with this process as well.
Yep. All right. I will share the link again here so that you guys can go. Yeah, actually, what we've been doing is just follow the cheat sheet. Yeah. So we are on the, we just passed actually the install OS part. And now we are going to configure the Raspberry Pi section. Okay. So can you see my terminal screen here?
Yep, I can see your screen.
Okay, cool. So how to connect to it? Here I'm on a Linux OS. All right, so I have already a terminal installed. I can guess many users will be on Windows actually, or on Mac. On Mac you have a terminal too, so it will be the same to connect as Linux. Please let me know if I say something wrong because I don't have a Mac. If you are using Windows, you will need just an additional program to have actually a screen like this. I can recommend something simple like PuTTY. This is in the cheat sheet. All right, so PuTTY is SSH connection software. All right, that you can that is very easy to use. Actually, you will just set the address of your Raspberry, and it will prompt you for the user and password. All right, so what we're going to do now is just exactly the same. The only difference, if your computer is running on Windows, is that you will need this additional program that is called PuTTY. All right, so I'm going to SSH. SSH is the protocol for distant access. All right, so it will allow me to connect to my Raspberry Pi because I'm on the same network than my Raspberry Pi. Now, you remember in the step before, I set user and password, right? My user was BLD, so I'm the user at, and I will type here the name of the Raspberry Pi that I've set while I was also setting my username. So it was astarpi .local, right? Let's go. So since this is the first connection, it will ask me if I trust this connection. So just type yes, right? And of course, it will ask for my password. Just connect to it. And this is it. We are actually inside the Raspberry Pi. Great, guys. You did most of the job, actually. You are running now a Linux OS on a small Raspberry Pi, which is really a real computer. You can do anything you do with a regular computer. For this one, we have installed the server version. So we don't have, user interface because we don't need it. Actually, a node will not run from a user interface. It's more than enough to run from the command line, actually, because even if you have an interface, you will have to use a command line tool like the one I'm using right now. Okay, so first thing we are going to do, all right, we are connected to it. We're going to make sure that the installation of the Pi of the Ubuntu OS is just taking the wall space. All right, so for this I will type lsblk. All right, type enter, and this is what I'm checking here. The partition here, which is slash, has to take the wall disk size. All right, most of the time you shouldn't have problem, but this is just a way to make sure that you will have enough space actually to run your Astar node. So right here, you can see this is my disk. All right, so since we're on a Linux system, I have a first partition, which is the boot firmware. All right, it's a very small partition that is used to boot the Raspberry Pi. All right, and the second one, which is my work partition. All right, so this is not how to say, we're not here in a Linux learning session, so I won't do all the basic of Linux, but everything you need to do is to follow my commands. All right, so let's go. First thing we do is to update actually and upgrade the OS to make sure we have the last version of the package. So I'm using sudo. What does it mean? Sudo means I'm going to use the root privilege And root privilege, well, it's just like on Astar. If you use the root, you can do anything. Well, that's the same with an operating system like Ubuntu. All right. APT, this is the package manager. You can compare it to your App Store, for example, unless only thing is that it's on a command line. It's a little less, sexy than your usual App Store. So I will go for an update, and I will add on the same command a sudo again apt upgrade. So it will ask for my password. Just type in your password and let it go for a few seconds. Do we have a question during this time? It will take a few seconds to update.
Let's see if there's any questions here. Got a question here. So how is the Raspberry Pi different from other machines running the node?
The main difference actually is it's a very small computer and that consumes very, very few power. And that's the magic of this kind of microcomputers, is that you can let it run at home, and for a whole year, you will pay just a few dollars of electricity for the whole year of using it. So your computer is basically consuming around 10, 20, 30 times more than the Raspberry Pi. All right. And it's very useful for a node. Why? Because we don't want it to be powerful. We just want peers here. All right. Let's make clear about one point. Having a node on a Raspberry Pi will not allow you to be a collator. It will not allow you to earn rewards for producing blocks. It's not powerful enough for this. But it will allow you to do many different things also. It will allow you to make a local RPC, for example. And, every time you connect to a Astar portal, for example, you actually connect to a RPC. The thing is, this RPC is distant, and you can have a long delay because there is the time, to ask the node, and the node process a lot of requests from other users. And this one is your own node, actually, that you can query directly. So you can connect, actually, once it is synchronized, you can connect Astar portal to your own node. And trust me, it will be much faster than when you use, a public node, the ones that you have by default into Astar.
And Douglas asked, does Astar node have to be up 24/7?
So it depends on the node, all right? If it's a collator, yes. But we just said that Raspberry Pi is not enough for a collator. So for the use we are going to do, and inside the peer program that we have launched, if you are up something like 80, 90% of the time, that's fine. You will get rewarded for this. We ask you to let it run, but if you have an outage, if you have a power cut at home, that's fine. You don't need 100% for the Astar peer program. All right. Maybe I will give a few words about the peer program by the end of the show, so that we are sure that people can apply to it, because this is the main interest of Astar right now, is to decentralize. And decentralize means having a lot of nodes. The more nodes we have, the more resilient will be the network. All right.
Nice. Yeah. Someone's asking, so what are the benefits of running an Astar node?
Yeah. So that's one of the benefits, is the one I gave just before, which is to run your own RPC node. So this is going to be in the next session. I will probably do a dedicated video, maybe not on Astar Talk, but it's kind of a bit more advanced. We have more things to configure on the Raspberry Pi to be able to connect to it, but it's really not a lot. Other interest is, everyone is talking about the light clients, right? Light clients allow you to actually run kind of your own RPC node inside your browser. But still, every light client needs actually some what we call boot nodes. Boot nodes, it tells the other node what is the chain they should boot on. Actually, it's really the name talks for itself. It will allow any node to boot on the right network, and that's the right client to sync. So this is probably one of the next steps of the Astar Peers program, is to make all this little Raspberry Pi or other small systems like this, able to feed actually the light client, so that everyone will be able to have a light client that is working and it will get the information the fastest way possible, because there will be a node close to him, right?
Yeah, that's right. Okay, interesting.
So of course, in the benefit to do this, Astar. I'm sorry, Dustin. I just finished this one, but that's the program I talked about, the Peers program. On Astar as a network, we want peers. We want maximum of peers, and these systems are perfect because they don't consume a lot of electricity. And through this program, we actually reward you $200 if you run it for the first month constantly on a Raspberry Pi. Make sure it's well a Raspberry Pi. And after 1 year, another $200 for people who are in a region where we want to cover. All right. So we'll see that in details just after. Yeah, please go on with the question you had, Dustin, maybe.
Oh, no, you pretty much answered the next question I had, was if the Raspberry Pi can run a collator, which you said that it doesn't.
Yeah, no, unfortunately, it's probably never going to happen, because on Astar, we have a lot of transactions. Astar is always has a pending queue of transactions full, and so we need powerful nodes to process this. So Raspberry Pi is not powerful enough for this.
No. Yeah, that makes sense. Morgan asks, is this paid in Astar? I'm not sure.
Yes, it is paid in Astar.
Okay, cool.
I will share the link to the Peers program while it finishes the
update. Someone asked, how many Raspberry Pis do you have?
I don't know. No, just 4, 5, maybe 6 with another one. Yeah, but I'm a tinker, and I don't use Raspberry Pi only for nodes, but you can actually use this, in different embedded systems. That's wonderful microcomputer. That's really awesome. You can do your home, automation. Yeah, everything about domotics. I don't know if you call it like this. Automating your home, but rather than relying on a cloud provider, you rely on yourself, with a Raspberry Pi. So, and that's consuming so much less power than a regular computer. And that's really interesting. Yeah. All right. So we're almost finished. I'm sorry, the upgrade takes a little more time than I thought. Okay, so this is just a message. Don't worry about this one. Kernel is the core of the system. Just say okay. It will ask which service you want. Just type on tab, the tab button. It will bring you to okay, and just type okay. Just leave the settings as default. Yeah. All right. So everything is good. My OS is up to date. What you're going to want to do here, I won't do it because it will take a little extra time and we are limited in time. You're going to want to reboot your node. So for this, just type sudo reboot. All right. And it will reboot by itself and you can connect to it again in just the next 2 minutes. All right. But it's not necessary, but after such an upgrade, like initial upgrade of your system, it can be always better to do. All right. So next one, we are going to need 2 different packages which are required to run the Astar node. So I'm just copy pasting from the cheat sheet, so you guys can just open in the cheat sheet. And so we are just going to install these 2 packages, add user and libconfig. All right, just type enter. Okay, and new world kernel available. Well, I will do that later. Yeah, you see, this is because I didn't restart my Pi, and I installed some programs. So I would recommend to restart after the first upgrade. All right, but it's okay. Let's keep going. So now we're going to do one thing, and I recommend to do that too, is to set a swap file. All right, swap file, what it is, it's a part of your disk that you will use as memory. All right, which means if you don't have enough memory on your Raspberry Pi, well, the swap file will take the relay as if it was an extent of the memory. It's very useful to avoid, the out of memory issues that can crash actually your system. So just type the 4 different commands that you have in the cheat sheet. So this one allocates a file that I will call file.swap. Okay. We're going to give the proper permissions, so only available to the owner. chmod is just managing permissions. All right. And we are going to make this file a swap. Okay, so still sudo because I need the root privilege to do this, mk swap, and make this file.swap that I just created before. All right, so see, just setting up the state, and I will turn on the swap with sudo swap on. All right, so right now my memory is actually available and extended with this swap file. I can go to check it with an htop command that will give my resources and my different processes. So you can see the first line are the CPU. And do you see my mouse over the screen or not?
I don't see your mouse.
Oh, okay.
Oh, no, yeah, there you do. Yeah, I do. Yeah.
Oh, yeah, okay. Okay, great. And so this line is the memory actually. So you see this one just has a 2 GB memory, and there is my extra 4 GB of memory that I use in the swap. So that will be very useful to make sure the node never stops. All right, so just exit with F10. And I'm gonna make sure, even if I restart my Pi, that my swap will always be on. All right, so just copy paste the command I put inside the cheat sheet. And all right, this will ensure that the swap file will be actually used at every restart of the computer. All right, you know what? Congratulations, guys, you have configured the Raspberry Pi. Here is the last part, which is installing the Astar node. So if you still have your cheat sheet under your hand, go to the install Astar node part. All right, and first thing we need to do is to download and unarchive the Astar latest binary. There is a big command that I put here, to make your life easier, but let's spice it a little more. Let's do it manually here. I will share with you how you do that. So if I share my screen here on the yep. So I'm here on the Astar Network GitHub page. All right. This is where we maintain all the Astar code and also the release. What we need is to download the latest release. All right. So I will just go in the release section, just click on it. And if you scroll down to the release, all right, you can see the download links here. You have 3 options. You can run it on Mac OS. You can run it on Ubuntu, on, let's say, classical architecture. The one that interests us is this one, AARCH64. Okay, so just select the third one, and you're going to right-click and copy the link. All right, so this is the link you want. Of course, feel free to use the quick command that I sent you. Just wanted to show you here manually how to download the latest version. All right. So let's get back to our SSH screen. All right. You should see my screen now. So to download it, I will just type wget and type the link I just copied before. All right. Let it download. It's about 50, 60 megabytes. So depending on your connection here. All right. So here I have it downloaded, but I need to actually extract it. All right. So to extract, I will use the program tar. This is the same principle than zip. It's an archiver. So I will just add some extra command xvf, which allows me to see how the process is going, and also which tells the program to unarchive this file. All right. And this is the name of the file that I just got from the top line. All right. Here it is. Now it's extracted. So if I look at what do I have here, ls is to look inside my current directory. I have here the Astar collator program that is ready to run. So before we run it, we're going to do just a few things that are good practices, let's say, to run a node. So first of all, we are going to add an Astar user. So this will be a dedicated user to run the node. All right. So sudo, just copy from the cheat sheet once again. I won't explain in very details, what are all of these commands. Here we are just creating the user. Once we are going to use the mv command to move to a location a standard location to put my program, my binary. So I move this, sudo move this Astar collator program to user local bin. All right, this is the directory I want to put it in. Okay, and I will make sure that the Astar user I will make sure it's executable. So actually you shouldn't need, because we do it by default on Astar, but that's, if you're using this with another, another chain, another node, you may need to do it. So chmod +x, which means +x means executable to, the Astar in the directory, and just put it in. All right. Now, what we are going to do is to create a dedicated directory for my database. All right, so we are going to store Astar database in this directory. The directory will be inside var lib, and I will create the Astar directory. Okay. Next one, I will make sure that only the user Astar will be allowed to this directory. Okay, so this prevents unwanted manipulations of the directory. All right, so chown. So, this means that this directory is the own of the Astar user. Okay. And finally, almost finally, we are going to create what we call the service or the daemon. It will be an automatic way to launch this program and to make sure it always runs. All right. So for this, I need to create what we call a service file. And the service file, in this service file, I will give, what the Astar node needs to run. Okay. So I will use the Nano editor, but of course use another editor if you have a preferred one. Nano is the easiest one to use. And so I will create this file into etc systemd system, and I will call it astar.service. All right, it doesn't exist for the moment. I'm creating it, and I will put some content into it. All right, so this opens the Nano editor, and then I'm going to copy paste everything I have inside my Astar node, inside my template of service file. Just a quick overview of the different commands that we are using. So it means here we are running with the user Astar, okay, and we are running this program that we moved Remember, we moved in the previous step to use our local bin, and we are using the program Astar Collector. Different commands here. What is it? Pruning archive. It means your node will actually save the world database. And this will be very useful if you want to use it as your own RPC, okay? It means you will save the entire Astar database on your Raspberry Pi disk, all right? RPC core all will be useful for later, actually, if you use it as RPC inside your local network. There is one thing I need to change here is the node name. So what do we call it? We call it ATT RPI. This will be the name that is displayed on Astar telemetry. You will be able to follow your node running on the Astar telemetry too. All right, chain Astar. Make sure it's Astar, unless you want to use Shiden or Shibuya. Okay, base path is the one we created just before for the database. So this is where the node will store the database. All right, RPC external and WS external will actually allow you, yes, to access your node directly from your internal network. All right, maybe I will remove this because maybe it's not super safe without doing the next advanced session. All right, so you can get rid of actually of these two parameters. They are not necessary for the moment. All right. Also, these are all related to RPC, so you can get rid actually of these 5 parameters. Yes, let's do it so that you don't get too much confused. Oh, sorry, I did mess up. So let me copy back. Okay, one coding ATTRPI, and we're gonna give it Dustin as name, and I will do it. Yeah, so I will just delete this line. All right, all good. Last one is just telemetry. That's just an external server that allows you to watch your nodes from anywhere, actually by anyone. All right, but just to watch a few metrics from your nodes. Don't worry, they don't access to your world node. All right, so let's just save it. Just type Control X, save modified buffer, yes, and just enter. All right, my file is saved. And now here is the time you are all waiting for. So what I'm doing here is, so sudo, we're using always sudo. We need root privilege for almost everything here. System control. So we will launch actually the Astar service right now. All right, so let's do it. Just system control start, Astar.service, enter, and this is gone. Now let's look at what this little node tells to us. So just copy paste from the cheat sheet once again, journal.ctl, and this will give you actually the log of the node on your Raspberry Pi. And here we go. So we are here on Astar version 5.4. You see the name that I just put here. It initialized the chain. It tells me a little more about my system here right now. All right, and here is the most important. Look at these messages here. It's actually thinking. All right. So what do these messages mean? I won't go much further. But it's important to just understand these two. An Astar node has 2 nodes inside this program. All right. It runs an Astar node, but it also runs a Polkadot node because it needs Polkadot to work. You know, Polkadot is the relay chain of Astar. So we need to be synced to Polkadot as well as Astar. Okay. So we have a relay chain and parachain, and the messages are the same. All right. So syncing means it's actually syncing right now at a rate of 115 blocks per second. All right. My target is the number of blocks I need to sync to be to have the world chain. All right. So here is Polkadot is more than 15 million blocks, and just under is Astar with a little more than 3.5 million blocks. All right. And then you have the best block, which is actually the block that you have synchronized, that your node has synchronized. All right. So it means you are here and you want to get here. All right. And how do you get there? Well, actually just wait. And it's gone for a pretty long time because as the Raspberry Pi is a small system, it will take actually a few days, even a few weeks to synchronize your Astar node and your Polkadot node inside. So yes, this requires some patience from now on, but you've done the best part, is to set your Astar node on your Raspberry Pi. Congratulations to you.
Congratulations, everyone. So I hope you guys follow the cheat. There's a lot of steps, of course. So you can play back the video here on Crowdcast, YouTube, and Twitter. Check out the cheat sheet as well. I guess we can follow up on some questions from the community. I know Douglas has a lot of questions. Let's see.
So I just shared again, just want to say I shared again, I will share it one more time, the link to the peer program. Maybe if I can have just a very quick word before the questions, and we're good to go, because I think that people will be interested in that. No, that's not this one. We're just trying to look at the screen to share. Here. Yes. Here we go. So yep, just paste it. Yeah, of course. Refer to the documentation on Astar docs. So docs.astar.network. You have more information about nodes. I won't tell you more about it today. And here is the peer program proposal. So please feel free to apply. We have at the bottom a link with a form to apply, and it means we are looking for node runners on Raspberry Pi in all of these regions. So in South America, Africa, West Asia, Southeast Asia, and Australia. If you are from one of this region, you can get rewarded in Astar for just running an Astar node on your Raspberry Pi. Okay. We will ask it to be on a Raspberry Pi or a small system like it. Why? Because we don't want you guys to run a big computer just to have a node running. All right. This is way too much consumption, electricity consumption, and we also want to be reasonable about it. All right. So we want you to run on a very small system that doesn't really consume pretty much nothing. All right. And so this is the amount that was requested, and these are the conditions. Okay. So please refer to this program, apply, and join our Discord. Inside Discord, get the builder role, and you will have access to the peer program channel. And I'll be very happy to chat with you guys inside this channel. Thank you, Dustin. Sorry for extra time.
Yeah, do you have some extra time to answer some questions for you?
Sure, I do.
All right. Let's see. Another question from Douglas. So I get the idea of having a node to participate on the decentralized network. Is this similar to my node? I guess that question was kind of asked.
Similar to my node? Like, what is your node?
Douglas, or if you're here, what's my node? Is that your specific node, or is that a type of node? So maybe you can get back to us on that.
Yeah.
Let's see. Yeah, another question from Douglas. Are these projects to have light clients, run collators, nominators, and validators?
I don't think so now, because light clients just run inside your browser, so it's made to be ephemeral. So if you want to be a collator, you need to be constantly active. That doesn't work with a local computer with a browser. You need to be hosted in a data center. All right.
Makes sense. Can you earn Astar from running a node?
So yes, there is the peer program that I just showed you. If you just have a Raspberry Pi and want to run it at home, so yes, we reward people who are outside of the usual zones, which means usual zones are, let's say, Europe and North America, because we already have a lot of nodes there. So we want to extend into other nodes. Otherwise, yes, nodes can earn Astar being collators. But being a collator requires pretty much more to deep dive, to have a strong server, to make sure of what you do, because there is a risk of being slashed. So this is a different topic, I would say.
Okay. So there's a chance for anyone to earn rewards here. So yeah, join our Astar Peers Program. And let's see, more questions from Douglas. Does Astar Node double as a wallet?
No, there is no wallet inside.
Okay. And can this be done on cloud?
This can be done, but this is not eligible for the Peers program for reasons I've said. Cloud is very energy consuming. But of course, if it's for your project, for example, and your project is running on the cloud, you can run an Astar node on cloud. Yes.
Okay, cool. Run a VPS. Interesting. And question for Bobo. Is Astar service going to start automatically on a device restart?
Yes, it will. This is the service file that we have created just before. This service file allows to restart in case of crash, in case of reboot. So once you have followed the instructions, actually, you can start your Raspberry, just turn it off for an hour, get it back. It will restart automatically.
Okay, cool. That's convenient. And then Douglas mentioned my node is a BTC and Litecoin node. I think that's what he mentioned before.
Okay, and the question was, does it run like my node?
My node.
I'm not sure I remember.
This looks like a device.
Oh, my node. Okay, it's a node. How to say? It's a different. It's a custom build of a BTC or LC node. Yeah.
Right.
I can't say if it runs like my node because I don't know about mynode.com. Sorry.
Yeah, this would probably be more of a cloud-based node. So if it did run,
I really don't know.
Yeah, if it did run, it wouldn't be part of the Peers program. Yeah, you'd have to have an actual device. So yeah, doesn't look like, to my knowledge. Oh yeah. If you have Raspberry Pi, please go ahead and try it out on that. We can't confirm if that is compatible. So what else can you do with the node, and how to use it as a RPC?
Well, to use it as an RPC, actually we can do another session. This requires just a little more configuration to make sure it's actually secure and you don't run it, you don't allow it to outside internet. Oh, you can want to do this, but it's never safe, to allow something from outside to run on your home network. So I guess we're going to do an extended session for this.
Okay.
But of course, you have all documentation on Astar docs. So feel free to have a look there, and I'd be happy to answer your questions inside the Discord channel.
For sure. I'll share our socials here, guys. So we'll be wrapping up here. Here's all our socials and also cheat sheet and Astar Peers Program. So that's still available for everybody to join. So if you guys are in that certain regions, definitely let us know. I guess just kind of a general question: where can you get a Raspberry Pi?
Yes, that's a good question because supply is limited, especially with difficulties on IT supply, IT hardware. I won't quote brands, but in in most online marketplaces, you will have some Raspberry Pi to buy. So I recommend a kit, that you can buy with. So it comes with the Raspberry Pi, with the case, and it comes also with the heaters I showed you here, because it's interesting. But also this a case like this that has a fan, that's really good. So even if it's hot at home, you're sure it's never too hot. And this kind of kit costs maximum $200. And it's a maximum. If you look right, you can have for $150 with a Raspberry Pi 8 GB. Yeah.
Oh wow, nice. Okay.
Yeah, it is. Of course, you have many different ways to cool your Raspberry Pi. This one is a passive one, but you see, this is all in metal. You can want to have something like this too. That's the thing. Once you get inside it, you will want to tinker it. You will want to do something else with your Raspberry Pi, because as well as being your Astar node, it can serve something else, like your local, your local NAS, for example. You can have storage at home on your Raspberry Pi. So these are all, pretty cool stuff you can do with Raspberry Pi.
Nice. Okay. I guess I'll just we can wrap up here. I don't see any more questions. But yeah, feel free to ask any questions. Anybody join our Discord, message us and we'll get back to you. And stay tuned for future Astar Tech Talks. We should be having another one this month. And we have a bunch of Twitter spaces happening soon too, so stay tuned for that. And that's it.
Awesome. Thank you, Dustin. Thank you, everyone, for watching. Hope to see you soon on Discord.
Thanks, everybody. Have a great day. See ya.
Yeah.